All right, so welcome to the FSE 2023 Rump Session. I am Tetsu Iwata, and I'm going to chair this session with Lin Song.
Hello everyone, I'm Lin Song.
Thank you, Lin. We hear you very well.
Okay.
So, before we start, we have some remarks. So for the Rump session, the authors were allowed to submit talks of 1 up to 5 minutes in length. And there are 3 categories. The authors can choose from serious ones, serious but funny ones, and joke ones. And remote presentations are allowed, but you will see the program that there will be no remote presentations. And for speakers, please respect the time assigned to you. If your time is over, I have this high-tech noise-making device with me, and we will use this to stop you. Okay? For the prize, we will reward the best talk or talks according to the matrix of entertainment, informative, or musical ones. We have this T-shirts with this logo here, mentioning the award in 3 languages. And Ling has some remarks on this, please.
Thanks. This T-shirt has a dedicatedly designed logo, just as shown in the figure. It prints the best Rump Session award with both Chinese and Japanese translations. It is literally translated to Chinese 最佳臀部奖. Yes, we are doing the Rump Session. And this translation is funny, but not perfect. If you have better, more elegant translations, come to us, and we consider to offer a bonus award. Tetsu.
All right, thank you. So here is the program. We received 10 submissions, and 3 talks will be from Beijing, and 7 talks will be from Kobe. So with that, we are ready to start the program. And the first talk is about Program Chair Report by Christina Bora and Bart Menning. So please.
Hello, just to be clear, you forgot to bring your device. So you first have to pass me to get it. So yeah. Okay, so welcome everyone. So this is the Program Chair Report. We must honestly confess we kind of copied it from previous year, but we updated the numbers. But that was a bit easier. So first of all, I really appreciate that there were so many people, so more than 100 people in Beijing, and also a lot of people here. So there's a huge amount of people that came here. Came to FSE this year, so that's really nice. So yeah, this is the typical slide you've seen for TOSC. I mean, since 2016. We had up to 2015, 2016, actually, we had the FSE, and then we changed to the journal style, this Transactions of Symmetric Crypto. It's published by the Hogeschool in Bochum. It's indexed and it's selected for inclusion in the Web of Science. We typically have like 4 issues per year. on a regular schedule, so always like the first of the month, except for November. But typically we have a deadline around every 3 months, and 2 months after that you get the notification for regular papers. For long papers, this could be extended, and this actually has happened last round. We have journal style decisions. So we had accepted papers, minor revisions, major revisions, reject and resubmit, which is basically rejection, but we encourage to resubmit at some point, and rejections. And we welcome regular submissions, systemization of knowledge, appendums, and corrigendum papers. So this is the typical schedule. So currently we are at FSE Y+1. It doesn't matter that much. This is the general schedule. So let me just go to the normal schedule right now. So we're at FSE 2023 of March 2023, and we have papers from the TOSC issue 2022 issue 2, 3, 4, and 2023 issue 1. And this is like that has been going on for years, and it will go on for years. Except for last year, there was the exception that for FSE 2022, we had 6 issues. But now we're kind of going back to normal. Not entirely, unfortunately, but we're kind of going back to normal. We have 4 issues here, and this is where we are right now. A bit of statistics. So in total, we accepted 48 papers out of these 4 issues. So that's on average 12 papers per issue. Yeah, we had 2 invited talks. So Siwei Sun already gave the talk yesterday. Tomorrow it will be Yosuke Todo. Yeah, and we have the Rump Session, which is happening right now. So with Tetsu and Ling Sung. So thanks for chairing the Rump Session. So some statistics over the year. Yeah, I mean, it doesn't say much, but it's a nice graph, right? So I mean, it doesn't say much because also the number of submissions kind of grows. You see a bit more submissions, these 4 issues. So the last 4 issues are the ones we're seeing this conference, the ones with a star. So you see the total number of submissions has increased a bit compared to last 4 issues. The number of accepted papers also has increased a bit. Yeah, what else can we see here? Not that much, right? No, this is, yeah, I mean, we kind of see there were quite a lot of submissions. A bit more statistics. So we had 184 regular submissions, and well, we accepted 48, so that's around 26%. Those were accepted. One thing that's interesting, and it was also last year the case, like major revisions actually often returned to TOSC. So for the last 4 issues, there were 21 major revisions resubmitted, and we gave 19 major revision decisions. So that's almost the same, but that's also because we have the cutoff at 2023-1, and now 2023-2 is happening, but that's for the next year. So there is this shift of 1 issue. Maybe I shouldn't call it resubmitted, because if a paper is a major revision, then it's still kept in submission officially. For reject and resubmit, the number is quite low compared to major revisions. So around 50% of the reject and resubmits return. So this is also statistics. So we had 13 reject and resubmits resubmitted. Okay, and 27 decisions. So again, there is also still the shift between previous and next round, but you kind of see this pattern. Also last year, we had a pattern of around 50% resubmitted. So SOCs, we accept systemizations of knowledge, but there were not many SOC submissions this year, 2 actually, and 1 of them got accepted. We also accept addendums and corrigendums, but none of them got submitted, and also none of them got accepted. So yeah, we had a quite big program committee, 43 people. So some of them are here, some of them are in Beijing. So maybe we should take a moment to thank all of them. Yeah, some of them are still in the new one. So we typically try to vary the committee quite a bit, but there is not always possible to have a new committee every year, of course. So another group of people whom we need to thank is, of course, Gregor, the managing editor of the Ruhr Universiteit Bochum. Well, for us, so not in general. Christoph Bayerlo, who did all the work of turning the accepted papers into published papers, and Linda Groos from the library. Kevin McCurley always helped us with the submission system. And of course, the general chairs, Bin Zhang in Beijing and Meijin. And Kobe, Takanori, and Fuka, we did a lot of work to arrange everything at the last moment here. Kevin and Kay, also thanks for organizing the virtual system here. So the virtual, the Zoom room and all this recording, that kind of stuff. And of course, thanks to the steering committee. So Anne, Itai, Or, Tetsu, Gregor, Florian, Maria, Thomas, Bart, and you. I don't know how many minutes I have left. 1 minute. Oh, okay. So then we kind of need to rush, but yeah, you don't have the device. So so we awarded 2 Best Paper Awards. Well, you already saw the Best Paper Award, so it will not be a surprise what it will be. But the surprise will be that they will get the actual award. So the first one is for Yusuke Todo and Takanori Isobe. So maybe you could come here.
We only have one, so we can cut it into pieces. Yeah. Don't know, want to.
Yeah, so thank you very much. I'm very happy to get this nice Best Paper Award. So thank you very much, Charlotte.
And the second one is the paper of Thomas Perrin and Chan Chan Tan. So I think you're also both here. So that's really nice that they're. Ah, Thomas left, but he. Ah, okay, yes, and.
That's good because you only have one. So yeah, you can just keep it.
Yes. And that's it. So thanks. And for the rest, I hope you're going to enjoy the rest of the Rump session and the conference.
Thank you very much. So the next talk is about news from the FSE steering committee, and the talk will be given by Ann Canto.
Thank you, Tetsu. So I serve as a chair of this FSE steering committee. Doesn't work? Okay. So as you might know, the FSE steering committee has set up this year a Test of Time award for FSE. And so the idea is that this Test of Time award is given every year to a paper which has been presented at FSE 15 years before. And so the principle is that we would like to honor a paper which had a lasting impact on our field. And so this year is the first year for this Test of Time award, and we decided to have not only one award, but 3 different awards. One award for this year, so for FSE 2023, but also one for FSE 2022 and one for FSE 2021. So this means that the eligible papers were all papers presented at FSE 2006, 2007, and 2008. And so all these papers were eligible, but also we invite everyone from the VFSE community to nominate papers. And so we received 12 nominations for these awards. And I would like to thank all those sending some nominations. And so let us start with the award for FSE 2023. 2021. So it's for papers presented at FSE 2006. So the committee was chaired by Or Dunkelman, but Or could not make it. And so Gaëtan will announce the winner.
Thank you. So this is the award from FSE 2006. It's given to a paper by Tetsuo Iwata, New Block Cipher Modes of Operation with Beyond the Birthday Bound Security. And so it was a difficult choice. There were many good papers at FSE 2006, but we chose this one because we thought it's a really nice and elegant result about Beyond Birthday Bound mode that unfortunately is not really used, but it would really be better to use it because it solves a lot of problems that we have now. So congratulations, Tetsu.
Thank you very much for the award. I would like to thank all the people who supported me and committee members. This paper was published 17 years ago. And since then, I have learned a lot from this community. And I hope that I can continue contributing to this community. So thank you very much.
So now the Test of Time Award for FSE 2022. And so this goes to a paper presented at FSE 2007, and Bart Menning was the chair of the committee.
Hello, welcome back, everyone. This is the award for FSE 2007, and the award was the paper that was chosen was the 128-bit block cipher Clefia from Taizo Shirai, Yoichi Shibutani, Toru Akishita, Shio Moriai, and Tetsuo Iwata. At least one person is here. So the paper was selected because of its kind of impact, the standardization, that kind of stuff. So congratulations for all the authors that are here. Congratulations for all the authors. Maybe at least one of them can come and you could have stayed here, right? So congratulations. You want to say something?
Yes. Thank you very much for this award. This really comes with a surprise. I'd like to mention that I'm here, but I'm just one of the members of the design team. And this is a result of the teamwork. And I'm really happy to see that this cipher remains a target for peptide analysis even today. So I really appreciate for this award, and thank you very much.
And so now the last one. So for papers presented at FSE 2008, we choose Tetsu as a chair so that he cannot get the award.
Hello, welcome back. So, okay. So the FSE 28 test time of the award goes to the paper by Hussein Demirci and Ali Aydin Selçuk. The title is Meet in the Middle Attack on 8 Round AES. And the paper proposes ground-breaking, powerful attack on the most important cipher. And the technique has wide applications. And we even see its applications in the quantum setting recently. So the paper has had a lasting impact to the field, and we would like to congratulate. Congratulations.
So now it's time to thank our general chairs for this event. And of course, I would like to start with our general chairs in Beijing, Bing Zhang and Mei-Hing Wang, because they had really a huge and very complicated job. Maybe some of you do not know or do not remember, but FSE was originally supposed to be held in Beijing in 2021. And so we had to postpone the conference several times because of COVID. And then also Bin and Mei-Hing, they had to deal with travel restrictions, with health restrictions and so on. And I know that really taking care of the organization of FSE has been a lot of work, especially for Bin in the last few weeks. So really, I would like, on behalf of the entire committee, I would like to thank them for making this FSE a great success. Thanks a lot, Bin and Mei-Hing. I'm sorry, unfortunately, I cannot give you the plaque in person, but for sure I will send it to you by post. And as you know, also because we had many uncertainty related to COVID, to travel restriction, we had to organize a mirror event for participants who had difficulties traveling to China. And while the organization of FSE in Beijing, it was launched like almost 5 years ago. The organization of the mirror event was launched roughly 3 months ago. And so I would like to thank Takanori and Fukang because they take charge of this event in a very, very short time. And I guess that finding a room, organizing coffee breaks, lunches, and even a conference dinner in such a short time, in a few weeks, well, that's a real tour de force. And this was a great success. So thanks a lot. And because now it's possible, I would like to give you in person the plaque. And also, we do not forget Kay and Kevin, who helped for the organization, because we have 3 different places, Kobe, Beijing, and also the speakers online. So each year we offer them a new challenge. And so, but they can always make it work perfectly. So thanks, Kay and Kevin. I guess probably one of them is here, is listen to yes. So thanks again, as every year, it was perfect. And so besides a very nice location and good food, they don't like the picture. So the success of the conference also comes from the technical program and selecting very good papers. It's difficult and it's a time-consuming task. And so I would like first to thank all members of the TOSC editorial board for their time and for the hard work. And of course, a special thank to Bart and to Christina. I know that handling 4 issues, it takes the entire year. And I guess that at some point it seems a bit endless. And you did it really in a remarkable way. So thanks a lot. And of course, you will get a plaque. Now I need to say a few words about the FSE steering committee, because we didn't have any election. We didn't renew the FSE steering committee during because of the pandemic, because we wanted to have some continuity to handle all these issues related to COVID. And so this is the list of the composition of the current FSE steering committee. So this committee consists of the co-editor-in-chief of TASK for the last 4 years, and also some elected members. And so what happens is that now almost all members in this list have goes to the end of her term, except Christina, Itai, Bart, and also Kazuhiko, who is our new chair for who is our new editor-in-chief for TASK this year. And so this means that we have to renew many different members for this committee. And so what we suggest is that these members will be elected by the current steering committee, but among a list of candidates, and anyone from the community can be a candidate, or anyone can nominate a candidate. For this, you only have to send me an email before the end of May. So if you want to be a member of the FSE steering committee or to nominate a member for the steering committee, please send me an email. Last but not least, what's about next FSE? So the plan is that we expect to have the next FSE in Belgium, in Leuven, so at the end of March, so you have the dates here. This is a plan because this still needs to be approved by the IRCR Board of Directors. And if it is approved, then the general chairs will be Svetlanikova and Simon Doge. And here are some pictures of the venue sent by Svetla. And for those who do not know Leuven, it will be at the train station, which is quite close at walking distance from the center of Leuven. And for FSE 2025, we do not have any plans yet. So if someone would like to organize FSE 2025, then you're welcome. So this was my last talk as chair of the steering committee, because we will renew the steering committee. And I must also add that I'm running for the award for the best musical presentation, but for copyright reason, I cannot play any music, but maybe I can play a little bit with that one. Thank you.
Thank you very much. So we'll move on to the next talk. This is God Save the Queen, clipped analysis of Elizabeth-4 by Henri Gilbert, Lachelle, Haim, Voici, sorry, Jeremy John, Jean Lene Leinhardt, and the talk will be given by Lachelle.
Hi, everyone. Today I'm going to present a work in progress entitled God Save the Queen, Cryptanalysis of Elizabeth IV. It's a joint work with Henri Gilbert, Jérémy Jean, and Jean-René Reinhardt. And I would like to underline the fact that although this is a pretty serious presentation, there is a song in the title of my paper. So, you know, and also just to do a little bit better than Anne, I'm just going to... There we go. Okay. So a few words about Elizabeth IV. It's a stream cipher designed by Cosron, Hoffman, Meo, and Standard that was published at AsiaCrypt 2022. And it is designed to be efficient in hybrid homomorphic encryption use cases. The authors claim a security of 128 bits. So I'm going to present an attack that fully breaks Elizabeth IV. And I hope it's interesting for two reasons. First, it's an example of an optimized linearization attack, and also because it uses an analysis of HHE dedicated features. So about the construction of Elizabeth IV, the key is made of 256 nibbles, that is 4-bit words, that And so the IV is fed to an extendable output function that outputs first a subset of 60 positions of the key register, then a permutation that permutes these positions, and finally a whitening vector that is added to the key nibbles. Then a filtering function is applied and outputs a key stream nibble. I would like to try and give you just the main ideas of our linearization attack. To do so, I need to just talk a little bit about the structure of the filtering function. So there are 60 key nibbles that have been extracted from the key register. And to simplify, so they are split into 12 sets of 5 key nibbles. 4 of these key nibbles are fed to a function h. So here it's hi because it's actually parameterized by the IV. And this function outputs 1 nibble. And the 5th nibble is just added to the output of this function. And then all the subsequently obtained outputs, are added to form the key stream nibble. So first, to attack Elizabeth, we are going to focus on the least significant bit of the output nibble for a very simple reason. It's because the addition in Z16 is simply a XOR on the least significant bit. And then what we do is that we are going to bound the number of monomials that can appear in the expression of the least significant bit of the key stream nibble. And this corresponds to the number of linear variables we are going to have in our system, in the linear system we want to solve. So at the input of, so remember that the key is 256 nibbles. And so and H takes as input 4 nibbles. So the maximum number of 4 nibble vectors that can be at the input of an HI function is 4 among 256. And for a fixed 4 nibble vector, the number of monomials that can appear in the least significant bit of the outputs of an HI is 2 to the power 16. But as you can tell, if we just do a naive linearization attack, we do not fully break Elizabeth 4 yet. So to improve our attack, we are going to use a handful of improvements. So first, we showed that the linear system we obtain is in fact very sparse, and we can exploit this to improve the complexity of the attack. Then we analyze HHE dedicated features, and we leverage some of their properties to improve the complexity again. And finally, we can do pre-computation-based trade-offs. I've given a little example here. So this allows us to obtain an attack that has time complexity 2 to the power 90 operations and pretty reasonable memory complexities, memory and data complexities. Thank you for your attention. And if you have any questions, please feel free to ask.
Thank you very much. So we move to the next talk. So the next talk is about AES level secure PRF by Antonio Flores, Uteles, Gregorianda, Ferdinand Sibileilas, and Josketo. And Ferdinand will give us the talk.
Thank you. That's the... So you all know AES cipher. It's one of the greatest cipher. It's a very secure. It's the random permutation. It has 10 rounds, and everyone uses it. So no need to present it. But you see, there's some kind of weird thing now. It doesn't fit my slide, right? I have to go back a line, and but there's a way to fix this. It's this construction. So now everything fits. And that is actually a random function. So there's in a lot of cases, you know, you want a random function. They are better than permutation because it's just keep for like AES GCM and everything goes beyond the birthday one, and it's great. And you can see it's secure because you have 5 and 5 rounds, so that's 10 rounds. And if you take above and below value here at the end, you see that they are separated by 5 rounds, 5 rounds, 5 plus 5 rounds. So they are computation indistinguishable. If you XOR them, you get a random value. So that's super great. And this construction is in a probably secure context. This construction is very interesting because you can prove that although 5 per 5 seems to be equal 10, 4 per 4 does not really equal 8. Because here you can use integral attack on 4 rounds above and below at the same time, and you have even some neighbors that overlap. So on 2 to the 48 queries, you have a distinguisher on this. So yeah, you may think that 4 per 4 does not equal 8. Not in all the case. I mean, if you think about again on restricted input, like for example a counter, unless you encrypt your counter in a very weird way, you probably won't be able to do this distinguisher attack that needs to manipulate the most significant and the least significant bit at the same time. It's not possible. So maybe even this construction is secure beyond Bose-Dayborn. We don't know. But what we really like is this construction. So it's super great because you actually with the native instruction in AES that makes AES compute really fast. You can actually compute 2 AES in parallel with those instructions. You can even do in parallel forward and backward round. So like, yeah, that's native instruction can do that. Like in 5 cycle, you compute everything, and on one instruction you do both R and R inverse at the same time. So it's really perfect. And I dare you to attack this, but let be known that we experimentally verified, and 5 per 5 is indeed equal 10. So we claim highest level security on this, and we think it's really the most simple PRF construction that can be done with all these AES round function. Thank you.
Thank you very much. So we move to the next talk. The next talk is CCA security with short tags, and the talk is given by Mustafa Kairala.
Thank you. So this topic is not really a new topic, so it has been studied, the CCA security of AED schemes. So there is this famous bound from 2000, which says that the CCA security of AED schemes is bounded by the CBA security and the integrity bound. But this was discussed during the NIST lightweight cryptography competition on the mailing list. And last FSE, I had a paper where I analyzed the attack that was described in the mailing list and also showed that the bound is tight for COFP scheme particularly. Subsequently, in this FSE, in the next 2 days, there is another paper that also has similar conclusion, and they show that the bound is also tight for ROCA, and they show that it is possible to have a bound that's not tight in the integrity if you have an encode then encipher scheme, but it only works efficiently for fixed plain text lengths. After that, you need an expensive enciphering scheme to be able to do that. So the first observation I want to present here is that the generalization doesn't work if the tag length is fixed, because if the tag length is fixed, then you have an attack where you try to forge an empty plain text and then you try to encrypt it. And if it's an ideal encryption, it's an outputs random strings, then at some point you will get something that leads to invalid plain text, but you get the same ciphertext from the encryption later. So you will be bounded by lambda. And you can show that if you set a fixed, like a minimum plain text length, and you have a random injection, then you can have a security that's the minimum plain text length plus the tag length. In this case, it's 0, so it's just the tag length. So yeah, if you want the security with fixed stretch or fixed tag length, you have to have a minimum plain text length. The second thing is that because these papers talk about online AA schemes, the natural next target is offline AA schemes like SIV, which is a 2-bus scheme. You first make the a plain text, and then you use the IV from the MAC as a IV for an NCBA encryption, and then you get the encryption at the end. So there is also an attack on this with the tag length, where instead of trying to guess the tag, you try to guess the ciphertext corresponding to the tag, and you can choose the ciphertext long to be the ciphertext length to be long. So you fix the IV, and then you try to get a ciphertext that corresponds to that IV. And this IV already appeared in one encryption query. And because you fix the IV, then the decryption becomes online, because this is just will be the same key stream. And if you get the ciphertext, then you leak the key stream and you can decrypt the message you encrypted at the beginning. And the probability of getting such forgery is depends on the tag length. So from these observations, we know that we have, if we want to fix tag length, we have the plain text must have minimum length. And if we have something like SIV and the IV can be controlled and the scheme is not NCCA secure, the encryption scheme, then it also doesn't work. So the natural next target is RIV, which was proposed in 2016 by these authors. And the goal was to have security with release of amplified plain text. So here we have a nonce-based variant of that. And I think like basically it's more generalized. We use different keys everywhere and we have a nonce. And if we consider a nonce respecting adversary, I think that this will have NCCA security that's double the tag length. So now we can short half the tag length and get the same privacy. And the reason it works is because you need to satisfy two conditions at the same time. So to break the NCCA security of this encryption scheme, you need to repeat the IV, but also you need to have this IV be corresponding to the correct message. And to satisfy those both at the same time, if everything is secure, then it will be double the tag length. Last thing I want to mention is that the scheme that was proposed in the Roca cryptanalysis paper is uses a 256-bit two-equal block cipher to get 256-bit NCCA. I think that there are ways to optimize it to use half the block size, but with a larger tweak, but again, this only works for a fixed plain text size. So you encrypt the message first, get an IV, and then you encrypt the message again, but with the IV as a tweak. So it's like SIV, but with fixed length. But now this encryption is NCCA secure. So it should be the same security as the encoded in cipher. And I think there is another way, but it's more complicated. So I don't present it here. I can discuss it after if someone is interested, to even have us have the block size with the original tweak size, but you will require 4 calls to do that, not 2 calls. Thanks.
Thank you very much. So the next talk is about step symmetric techniques for advanced protocols. And the talk is given by Leo Perrin.
Thank you. Well, pretty much all of it is in the title. So the questions I'm trying to answer here, well, not here, actually, it will be in Lyon, as you will see. Why would anyone want symmetric primitives over FP? I found F2 pretty comfortable since you cannot make any sign mistakes, and also we have literature on the topic. But it turns out there are actually good reasons to do that. But when it's the case, what do we need to know when working in these fields? Because when you go from F2 to FP, there are quite a few things that change. Well, I hope to provide some answers, or rather to have people provide us the answers at STAP workshop. I was also trying to get an artistic prize for this Rump Session talk by having my students do a logo for me. So thank you, Clémence, but apparently it's not going to work. It's only music, right? So again, it will be in Lyon, actually where I studied. It's going to be the weekend just before Eurocrypt, not FSE, to be a bit late. So the weekend just before Eurocrypt, and how to get there, or how to register in this instance, you need to sign up when you register for Eurocrypt. I have put a tentative outline of the schedule. It's a bit complicated because it will be invited talks, and I will have guests who will tell us about algebraic attacks, Starks, how to design and use permutations over FP, how to actually do the arithmetization step in a zero knowledge protocol. Also about side channel resilience, which was not something I expected to be relevant here, but actually it really is. FHE, symmetric design, and also a topic dear to me, standardization. I was not expecting that. Well, anyway, here's the URL. You can also find it on the Eurocrypt website, and I'm going to run away before the ghosts get me. Thank you.
At least it had symmetry.
Yes.
Test.
Test. No, there's still a problem. Test. It's okay. Okay. All right. So the next.
Meanwhile, please read the slide.
Okay, now it's okay. Okay, so let's continue. The next talk is about the third NIST workshop on block cipher modes of operation 2023 by Nikki Moha, and Nikki will give us talk, please.
Thank you, Tetsu. So I have a workshop announcement as well. The workshop will be held on the other side of the world with a 13-hour time difference. So I'm the only person here of actually quite a big team in DC working on this, sent over to tell everybody, please come to DC at the end of the year. So we're having a workshop on October 3 and 4 at the National Cybersecurity Center of Excellence, which is a building that is part of NIST, but closer to DC. It's also a newer, nicer building. The workshop will be related to the upcoming standardization of new mode of operation. So we're discussing what type of mode of operation that would be, what requirements would be, and what the problems with the existing modes are. Just today, there has been a document released, NIST IR 8459, that discusses the issues with the current modes of operation and the possibility of standardizing a tweakable white encryption technique. So white, like the width would be the width of the entire plain text. So in the case of the CSER competition, I think only AEZ was the submission that satisfied this property. So please send your submissions. The submission deadline is July 1, 2023. Here you see notification July 30. Workshop will be held October 3 and 4. And below are some links to find more information. Thank you.
Thank you very much. So we switch the screen to Beijing. So one moment, please. Eileen, we see the screen. Yes, please.
Okay, we switch to the Beijing venue. The next talk is entitled New Records in Collision Attacks on RIPE-MD 160 and SHA-256. Yinxin will give the talk. Welcome.
Okay. Our new records include collision attacks on rapid MD 160 and SHA-256. The causes is Liu Xin, Liu Fukang, and Wang Gaoli. Our results on the rapid MD 160 and SHA-256 has two main results. The first is we found the first practical collision for 40 steps of rapid MD 160. And the second is the first practical semi-freestyle collision for 39 steps of SHA-256. The rapid MD 1660 is ISO IEC standard, and SHA-256 has been widely used in the world. The program to fund semi-free star of 2 hash function is slow. For rapid MD 160, it's a special dual branch structure, make it a difficulty to perform the message modification on both branches. And finding different characteristic is not easy, because its run function is more complex. We carefully analyze the stable function and the message expansion. We found that by injecting difference in the new message words M0, M2, M11, and M12, we can construct a local cleansing for the last 30 steps and last 16 steps on the left branch, such that we clean the attack on the 40 steps rapid MD 160 is possible. With our SAT SMT based tool, we have been found the 40 steps differential characteristic as shown in this table. To find the conforming message pair, we mainly use the SAT SMT based technique and the dedicated freedom degree utilization technique. We present the first cleaning message pair for 40 steps rapid MD 160. For SHA-256, its run function and the message expansion are much more complex, which make it a difficulty to find clean generating differential characteristic. Inspired by the 39 SHA-512 semi-free stack laser attack, we use the same method to inject the message difference. We use the SAT MT based method to find the differential characteristic for 39 steps SHA-256 as shown in the table. We use the motoring technique to avoid the contradiction. Then we use our SAT and SAT SMT based method to find the conforming message pair as shown in this table. We also display our result on rapid MD 160 and SHA-256. Okay, that's all. Thank you.
Hello,
Okay.
everyone. We Andrew Willem Roscoe and me would like you to join a lovely British tea workshop. So what does the T stands for? timed release encryption and its application. It is an international workshop to be held in Oxford, United Kingdom. So we are sponsored by crypto.com. The date is June 26 to 27. It will be held in Oxford. The host is Department of Computer Science, Oxford University, and it's also co-organized by Blockchain Research Center, Shanghai Jiaotong University. You can see the website. Well, the goal is to promote the research in the field of timed release encryption and its application. So timed release encryption. So the main goal is to make software encryption slow again. While more precise, we hope to, the technique is hope to make encryption the time more controllable. But yet it's still in the scope of symmetric key encryption. So you can combine the symmetric key encryption and the time-consuming components. And also similar primitives, timed commitment, timed puzzle, and all of these primitives have applications to security protocols, blockchain, and we welcome your ideas on design, analysis, and implementation. We expect to bring researchers from around the world. The speakers are mainly invited, but if you have very good ideas, we are open and excited to hear it. And our audience are open to generic public. Please contact us as soon as possible to reserve a spot. Again, this is the information. And if you are interested to give a talk or to attend the workshop, please contact Evan. Thank you.
Thank you. The next talk is entitled The 10th Asian Workshop on Symmetric Key Cryptography. Yao Bing will give the talk.
So I'm going to make an announcement for the 10th Asian Workshop on Symmetric Key Cryptography, the ASK 2023. And so there's some delay. So the day will be from December 9 to 11 and this year, and just after the Asian Club 2023. And the venue will be in Jidan University, Guangzhou, China. So you can contact me or Ling Song for more information. The website is already online, but we will update the information soon. And so the goal of us is to promote the research on symmetric key cryptography in Asia. The topic will be including block cipher, string cipher, hash function, most operation, and their corresponding analysis, design, proofs, and implementations. Any researcher, even not based in Asia, is welcome for participants. We also provide limited number of stipends for PhD students who have difficulty obtaining the fundings. And the format asked will be morning. Will be the invited talk sessions. We invite the respectful speakers to introduce the advanced results and also the survey on popular topics. And in the afternoon, we will divide the participants in working groups. And there will be some small discussion group and working on a particular research topic. And the goal is to face their cooperations. For the previous ask, the first ask is in 2011 in Singapore by Jian Guo and Thomas Pehang. And then in Japan, China, India, Singapore, Japan, China, and India, Japan. And due to the COVID, the 2020 and from 2020 to 2022 are cancelled. There are some publications related to us, some paper in the ICR main conference, also many paper in the FSE, also in other venue like ACISP, ACIS, or the SEC, also in the journal like IESC or design course and cryptography. We also have some statistics regarding the venue, Guangzhou. Guangzhou is very famous for its delicious food and also tourist attraction. For the food, I think there are more than 1,000 dim sum and also thousands of desserts. And for the tourist attraction, I think more than 223 million visitors will come to Guangzhou just for traveling. And you can visit the Kangdong Tower, a mini museum of paradise. So welcome to Ask 2023 at Guangzhou, and from December 9 to 11. Thank you.
Thank you very much. This is the end of the Rump session. Please wait a minute. We will announce the result of the best Rump session award soon. Tetsu, could you announce the result?
Do I announce the result? Okay. Okay, the best Rump session award goes to God Save the Queen, cryptanalysis of Elizabeth IV for its informative talk. Thank you. So we have 3 T-shirts. Okay. There is no choice for the size. I'm sorry, Pat. Congratulations. Okay, Lynn, this is yours.
Which one do you choose?
One moment, please.
So I just let Tetsu to decide the best Rump session talk in Beijing.
Okay, so from Beijing, we will choose new records for RIPE-MD 160 and SHA-256.
Okay, then Yinli, could you come up? The best talk is the new records for RIPE-MD 160 and SHA-256. Where is the new author? Congratulations. Would you come over? I have prepared 4 T-shirts from size from S to XL. You can choose 3. Oh, you can choose 3. The size. Okay, congratulations to Lingli. Thank you. Thank you all. This is the end of the Rump session. Thank you all.